we have Matt Menzenski of Payitgov. Very excited to have you on and talk about how they have been unsticking themselves from Glue. So they recently migrated all of their data pipelines to Argo workflows and Hera. Just trying to get that under control, just completed that. We're so excited to hear about how that is going and what challenges or pitfalls you ran across along the way, and what kind of hope and optimism you can share for anyone who wants to do this in the future. So welcome, Matt, and please take it away.
Thank you very much for giving me the opportunity to talk today. I'm excited to share a little bit about our journey into a Kubernetes native data ecosystem. So I'll give a little bit of background. I'll talk about our legacy data infrastructure a little bit. I'll talk about our first attempt, our first iteration of a new data warehouse, some of the challenges we ran into with AWS Glue in that build out, and then a migration into Argo workflows and sort of where we are today. So first, who's PayIt? We are a SaaS platform. We provide a self-service portal for essential government tasks. Depending on where you're located, if you're in the US or Canada, you might have used one of our applications to do something like renew a vehicle registration, pay personal property taxes, pay utilities or water, pay your utilities like water or refuse, get a copy of a professional license, all of these like little kinds of day-to-day mundane government interactions we're trying to sort of make easier. For agency users, we also provide a self-service portal and kind of a back office tool to allow doing things like updating the status of an application, looking at payment details, issuing refunds, viewing reports, handling, disputed charges, things like that. And our clients include various cities, counties, and states in the US and Canada. Our platform, we sort of pride ourselves in being cloud native. We've been deploying Kubernetes in production since early 2016. Our platform has always run in a microservices architecture, almost from the beginning on Kubernetes. It's all AWS. We're in EKS now. In late 2022, we migrated to GitOps with Argo CD for all of our application deployments. All of our Kubernetes infrastructure is also now managed with Argo CD. We're also big users of Terraform. A lot of our database infrastructure, et cetera, is all managed with Terraform. I think now in total, we have 6 environments across 14 clusters, multiple production environments for US and Canada, and production could be split into a couple different clusters depending on restrictions for things like card processing, et cetera. Our US production environment is in the AWS Gov Cloud. And I think we're something like 130 microservices today. Most of those are Java, a couple are Node.js. Our transactional data store is MongoDB. We have one big MongoDB cluster that serves most purposes, and we've started kind of slowly migrating some things away from self-managed MongoDB and into AWS Document DB, depending on service use cases where they need special handling. Our infrastructure for data, a lot of it dates back to fall 2017. Before we actually had a data team at PayIt, our infrastructure team stood up a database that we call the oplog database, or sometimes the oplog warehouse, because its source is the MongoDB operations log, or oplog. If you're not familiar with MongoDB, the oplog is a capped collection, which the members of a replica set use to stay in sync with one another. So you write against the primary member of the replica set, it writes to the oplog, and the secondaries will read the oplog and apply those changes to themselves. And we have this sort of set of 2 Java services and an AWS Kinesis stream that reads messages in that operations log, publishes them to AWS Kinesis, and then this other Java service consumes those records from Kinesis and writes them as JSON to this Postgres database. And it's very dynamic. It uses a Java ORM, and it creates tables dynamically as new records are inserted. And so you sort of end up with this, not really a warehouse per se, but it's a Postgres copy of the MongoDB upstream transactional database. This oplog database, this Postgres database, also has been the source for most of our financial reconciliation reporting that the data team owns. The benefits of this approach are it's very low engineering cost because it's so dynamic. And it really was great for us as an organization. It bought us a lot of time to be able to have sort of this relational analytics database without requiring the investment in the data team at that early point in the business. And you sort of basically get your data immediately, right? As changes are applied to the, the oplog and the members of the secondaries in the replica set, they're also effectively immediately available in this Postgres copy. So you can sort of see data as it happens, even if you're in the analytics database. However, it's got drawbacks, right? It's very tightly coupled to MongoDB specifically. AWS Document DB implements the MongoDB specification, but the operations log is not part of that specification. It's an internal feature of MongoDB, and Document DB doesn't support it, right? Document DB is separate compute and storage versus Mongo. It's pretty different. So as we migrate a service from MongoDB to Document DB, it no longer is able to be replicated to this analytics database. And so that's a decision we've had to, do I create a new service against DocumentDB or MongoDB? Well, does it need to be present in this analytics database? Okay, it has to be in MongoDB. We don't like having that, our hands sort of forced in that way. Tables are created dynamically, but you don't get anything for free around indexes or constraints. And so you often get into scenarios where there's a new database collection in Mongo, and that creates a new table in the warehouse. And then people start trying to query it, and they say, hey, it's not performant. And you have to go look at how it's being used and where you can add indexes and do it all kind of after the fact rather than be proactive about it. Also, everything is JSON, right? MongoDB is BSON, essentially just a JSON blob coming in through AWS Kinesis. And so this application that writes to this oplog database does one level of object flattening, but if you're selecting information from this database, you'll have to do a lot of further flattening, lateral joins, JSONB array element, a lot of complicated queries to be able to join two tables together. And that's sort of a burden on some of the business analysts who maybe don't have that skill set. And finally, it works fine until it doesn't, right? It's great that it's a low cost of ownership. It's great that it's hands-off. And then something goes wrong and everybody's scrambling because there's not a lot of familiarity with the processes around it because it's been hands-off. So for a lot of reasons, we were looking to migrate away from this. The data team has grown. We've hired a real ton of database specialists onto our team. And so we've said, okay, now's the time. We're going to build the next generation PayIt data warehouse. So what does that look like? Well, we had some design goals we wanted to meet. The big one is support our needs in the future and today, right? Where we were finding that our current approach had served our needs well for about 5 years, but it's showing its age. It's not going to meet our needs for very much longer. So we need to meet our needs for today, and we need to build for the next 5 years or longer. So historically, a lot of the needs from that analytics database have been reports that the data team, like Python code base, runs and sends out daily to our client users to do financial reconciliation, a record of what was paid and what was transacted and what we will be dispersing to those clients, et cetera. However, we're also now getting to a point as a business where we want to do a lot more BI. We want to have sophisticated dashboarding tools. We want to be exposing customizable analytics dashboards to our agency users inside our back office tool. We want to support multiple BI front ends. So we have AWS QuickSight that we use for a lot of internal uses. And also we kind of white label in our admin tool to expose to agency users. We also have an executive team that wants to live in Tableau. So with that in mind, we want to push a lot down into the database and rather than have it implemented in two different BIs. We also really wanted to support this idea of any data source is a first-class data source. Remove the tight coupling that the previous database had with MongoDB. We want to be able to support MongoDB. We want to be able to support AWS Document DB. We want to be able to support any third-party data source. We want it to be performant. We want it to be managed via automation. Like I had said on a previous slide, we have, 6 environments. We want to be able to put this in all environments and not have to have data engineers sort of manually applying database changes. And we also just want it to be manageable, period, right? The data team has grown. It's still not very big. There's 3 people. We want it to be able to sort of handle all of it ourselves as much as we could. And so we started out in a way that had a lot of similarities with the previous model. So instead of this Java application that would read the op log and publish to AWS Kinesis, we had a new Java application that would read from the MongoDB change stream and publish to Apache Kafka. I had said that this first generation of infrastructure was created in 2017. Kinesis, I think was selected actually because Apache Kafka wasn't yet available in AWS GovCloud. Since that time, we had adopted Kafka more broadly, and so the Kinesis use case was kind of an outlier. So we said, okay, we'll adopt Kafka instead for pushing this data around. And also the previous infrastructure, the previous database had been created and put into production, I think just a couple weeks before the MongoDB change stream API was like made public. And so the change stream API, unlike the operations log, is a public API. DocumentDB does support it. And so we thought, okay, we'll build this against the change stream and we'll get MongoDB and DocumentDB support. And so this Java application reads the change stream messages, puts those into an Apache Kafka topic. We have an Apache Kafka Connect service in our managed Kafka provider that writes that to AWS S3. And then that's kind of our data lake. And then we also have a Postgres operational data store, and we'll have this AWS Redshift dimensional warehouse. And the data team had been very familiar with AWS Glue. We'd been using it for years for all of our sort of financial reporting jobs. And so we thought, hey, Glue's an ETL tool. We need ETL. We're just going to leverage Glue. This is what it's built for, right? And manage everything that we can in Terraform for infrastructure and AWS resources, and things within the database we'll manage with Liquibase. Liquibase is an open source tool that allows you to automate database changes from Git. And we ran into some challenges. Managing AWS Glue with Terraform got really challenging really fast. We had tried to implement our Glue jobs as sort of small focused jobs that would do one thing. And then to have a Glue workflow that sort of called them all in the right order so that one would run dependent on the previous one's success, or you'd have a failure handler if the previous one failed, that kind of thing. And to do a Glue workflow like this, you have all of your jobs, and every job also has to have a separately defined trigger, which is the conditional, run the next thing if the previous thing succeeds or fails, whatever that definition is. And you can see the diagram here. The words aren't important, just the complexity is what I want to signal. We had 43 jobs. Each of those had its corresponding trigger, something in the neighborhood of 85 or 90 resources managed with Terraform. And we were only pulling in from the platform a tiny percentage of the data that we wanted to expose in this data warehouse, right? Like, we're a payments company. We process a lot of payments. We had started by pulling in sort of the core payments collections from MongoDB. We hadn't yet pulled in any of the customer information or the information about what accounts and bills were being paid, any of these other things. We had just been pulling in a small number of these payment collections, and our workflow was already so complex that a pull request review just to run Terraform plan could take 40 minutes or an hour or more. Very cumbersome. And it became apparent pretty quickly that it wasn't going to scale very well, because we have 400 database collections in Mongo, maybe more. We wanted third-party sources again, right? This is very complex. And furthermore, just the developer experience was really poor. We had been coming from this AWS Glue background where we were just using the Python shell environment, just running pure Python scripts for our financial reporting. With this data pipeline, we were using the Glue ETL, which is PySpark, and it was really challenging to set up a local environment to run PySpark. We had this new JVM dependency for our local developer environment. We were having to jump through hoops to get a test in GitHub Actions that would stand up the Spark JVM resource and run tests. It was very hard. AWS Glue, I think, no longer publishes a Docker image for the current version of Glue ETL, so we couldn't have a good way to replicate the Glue environment locally. And there are ways to do this within Glue with endpoints, but that was really hard to set up as well. And so we found ourselves with this workflow that really wasn't ideal. We had an existing Glue job We would copy it in the Glue console, make our changes there, run it, and see if it succeeded or failed. It was very difficult. And the ETL, extract, transform, load order was also really hard for us because it was difficult to find what had failed. If you see an error, you have to go back and sort of try to replicate the data frame at that point and see what the error is. We had a lot of problems. We also were just spending more time managing Glue and managing this environment than we were actually solving business problems. Right? We had to write our own handlers to say, record the job's success or failure, record when it started and when it stopped, all these things that sort of Glue didn't provide even in this workflow idea. And fundamentally, that meant we weren't able to ship as often as we wanted. We had all of these complicated steps that had to happen before we could deliver to the business, hey, here's a fact table that you can hit in your BI tool. So what do we do, right? We have this problem. We can't deliver quickly enough. Our workflows are cumbersome. We decided to throw everything away and start from scratch, essentially, right? Remove all of the complexity, like, hey, this isn't working, that we have all these hoops to jump through, only to deliver a fact table and find that in the time it took to build this out, requirements have changed and they're not looking at it now, right? We want to be able to ship quickly to the business. We want to remove all the complexity we could and focus on tools that we can use out of the box or existing open source tools, things with good documentation and good communities of practice around them. And we really just were frustrated by the pace at which we were moving. We wanted to move really quickly and we were not. And so over sort of holidays, end of 2022, beginning of 2023, we ended up on selection of some core tools that we were going to use to propel ourselves forward. Meltano and DBT were really big ones for this, and I'll get into a little bit more detail in the next slide. But Postgres over Redshift was one where we said, you know what, we can do Redshift later. Postgres works great for us now. The JSON handling is great. We know how to make it performant. Consistency with the other databases we own. We're just going to go all Postgres and no Glue, no Terraform. So Meltano, we actually sort of discovered by accident as we were researching data transfer specifications, or I forget what search term we were using, but we found the Singer specification, which the paid tool Stitch is built on, Stitch data. Singer is an open source specification around data transfer, defines sources and destinations as taps and targets, and it defines a schema for data moving between these two things. Meltano is an open source CLI tool built on this Singer framework that adds a lot of useful abstractions over it. There are hundreds of open source connectors. It's just Python. There's no JVM. There's no additional complexity there. The user experience is great. I can run it locally, easy peasy. And it supports utility plugins. So I can invoke DBT, the open source DBT core plugin within a Meltano project. I have this one mono repo that contains everything. It's deployed all at once. It's all together. It's great. But, right, how do I run this CLI program? I can run it locally. That's great, but that doesn't scale. A lot of people in the Meltano community run Meltano in production in Airflow or in Dagster. And again, we are trying to limit all the complexity that we can. So I don't want to adopt Airflow just to run this other tool, right? I don't want to adopt Dagster just to run Meltano. Those are complex things we didn't want to do. But we are a cloud native shop. We've been running on Kubernetes for a long time. We have a lot of Kubernetes experience on our platform engineering team. Let's just run Meltano in Kubernetes, right? Meltano is published with a Docker image. It's easy to put in a container. Kubernetes is great at running containers. Oh, wait, this isn't a service. This isn't something that you start up and it's just going to stand indefinitely there and serve requests as they come in. This is a workflow. It's got to start and stop. Well, it turns out Argo Workflows solves that problem too. It gives us a way to run workflows, jobs that start and stop and can be scheduled and can have relationships with other jobs in Kubernetes. And so we can leverage all of our existing Kubernetes infrastructure. We can use our Argo CD GitOps deployment strategies to deploy these things. Our logging just works. Our distributed tracing just works. And so we went whole hog with Argo Workflows. And again, we ran into some complexities there. We have a lot of workflows. I think just from our data pipelines for this new data warehouse, we probably have 500-600 across our environments. And now in the last couple of weeks, I think we've added something like 2,000 more Argo workflows jobs. So it very quickly became sort of infeasible to manage the YAML ourselves. But there's a great solution for that too with Hera, which is a Python package available on PyPy, the package index, that provides an SDK for Argo workflows and Argo events. And so we're a data team, we do Python and we do SQL. We can stay in Python the whole time now. We can write our Argo workflow definitions in Python. We get type safety. We get validation of the arguments we're passing. It's simple to script, and I can say, here's a list of inputs, generate a workflow for each of them. And we can hook that into our GitOps workflow really easily, because on any of these Hera resources, there's a function that produces the YAML. So I can make a pull request against my mono repo to add a new Meltano job, to add an Argo workflow definition in Hera in Python that runs that Meltano job. And when that PR is merged, the YAML is automatically put into the GitOps repository and it just goes out. All one PR. It's great. So I know I'm a little pressed for time. I'm going to try to wrap this up real quick. The short version is we are moving immeasurably faster now with Argo workflows, with Hera, with Meltano, with dbt than we were with AWS Glue. In all of 2022, standing up the data lake, standing up the operational data store, standing up Redshift, standing up these Glue pipelines, with all of the effort we put into that over the course of an entire year, and granted, we had other commitments, we really didn't have much to show for it. We had, I think, 2 fact tables and related dimensions that were accessible to the business users in the BI tools. And that was too few, right? That's not enough of a deliverable for that much effort. Since beginning of this year, I think we have exposed to the business in the BI layer 170 Mongo collections, a bunch of collections from our AWS DocumentDB collections, a bunch of external data sources, and we can turn data around so quickly now. Again, I mentioned it's just really one PR to do everything, to add the Meltano job, to add the Argo workflow, to add the DBT transforms. We can turn around a request for new data in the warehouse within a day. And that's really been critical for some of the things that have come up recently where the business says, hey, I really need to do this presentation. I'd really love to have this data, but I don't see it. We can turn it around in time now. And then it's there for everybody. It's updated automatically with the Argo schedules. It's been really wonderful for us. So thank you everyone for letting me share that part of my journey. I'm happy to entertain any questions in the DoKC Slack or here in the chat or wherever. Thank you.
Thanks, everybody. Have a good one.